This is a friends and family video showing what I've done with my mill. If it turns out generic enough and decent enough, I'll probably just post it publicly in case it'll help anyone out. But I am not a YouTuber, so don't expect real high quality videography or dialogue for that matter. So what's happened here is I picked up a mill, 3-axis, or with 3-axis DRO from a guy that was leaving the country, in fact, and I got a really good deal on it. It's a Central Machinery mill. I'm guessing probably early 2000s, best I could tell from all the stuff I've looked at. Anyway, came with stand, came with the DRO. He'd already installed it, or maybe he was second owner, I don't know, but it came with a real nice Grizzly DRO. What it didn't come with, which I wasn't prepared for, having cut my teeth on Bridgeports and other machines that had a lot of, I guess, what might be considered advanced features for the hobbyist, but probably pretty normal for most machine operations, such as X drive for the table, even drive for the Z, a variable speed on a dial. I really miss that as far as stuff I do at home versus work. Mine's belt driven, so I've got it set for 800 to 1000 RPM. That's pretty much cuts what I would do in aluminum, so I don't change those speeds very often. And I got this little, I think it was $35 magnetic base adjustable arm shield for basically for deflecting chips. I always wear safety glasses. They're right there, but I work in my garage, so I get to sling in chips. It's not so bad when I'm slinging them at the wall, and yes, I do move all those battery chargers and etc. out of there before I do that, but when I'm slinging them going in the other direction and they're flying across the garage, that creates way more cleanup than I wanted, so the deflector works really well. So anyway, the project there was to put a motor on the X-axis, and there's a lot of videos out there. I encourage anyone that may be watching this that's looking to do it to go watch all the videos. I watched very many different videos, and I'll tell you right now that there's guys out there that did way sexier setups. You know, there's a guy out there that has a really good set of videos on machining, and he built a clutch transmission box, aluminum, and it's a German feller. I don't remember his name or how to find him. You guys will have to search for him, and you'll find all kinds of cool stuff when you're doing that. But he built a real nice setup. And there's another guy out there that's got I think a 4-part series. He did his is actually more what mine is based off of. I just modified it somewhat. But the motor, which is a 12-volt power seat motor for a car, that was per his video and what he did. And same with the electronic speed controller. I used a different box to house all my parts and pieces, but the LCD on-off button and speed knob come with all-in-one. I think they were like $12, $14 off Amazon. And then I bought the double pole, double throw switch, so I'd have off, right, and left to reverse polarity to the motor, obviously. And then I just mounted all in this snazzy little electronics box, or hobby box rather. So a couple things that are different. I didn't want to modify my mill. Most all of these other videos I'd seen, they required, you know, drill and tap of the table, some other kind of you know, minor mod, you know, all things considered, but it required you to do something. And as you can see, I already have a mod, which probably would have been in the way, so it would have been a mod to a mod. But this is the rail for the encoder for the X-axis on the digital readout. So I didn't want to do that, and I fiddled around and came and tinkered, and you'll note that everything here is scrap. Just point that out. It's all scraps of things that you know, I've cut down, repurposed. This was a bar. I didn't do much to it other than size it lengthwise and a rail. I'll show you how I made the interface here in a second. But I wanted to come up with a way not to modify the machine itself, and so that's, in the end, that's what I did. I'm not the guy that's super worried about making it, you know, look manufactured OEM part, or, you know, super polished or anything like that. I want it to work. I want it to be easy to modify and improve, or to take out of the way. You know, I basically just wanted to make the process better and get back to making things. So yeah, I'm sure there's 100 different ways people will notice to improve upon the look of it, but simplicity is what I'm going for, and functionality, and so it does that. It does that simply, I guess is the best way to put it. Where to start? So to clarify, this is a drive motor. Instead of me having to stand at that end of the table and crank the handle back and forth, I've removed the handle and replaced the handle on this side with the motor mount and the interface, and we'll talk about that here in a second. So if you, hopefully I'm not making people dizzy, but if you look, I can stop the table and go back in the other direction, and by adjusting the knob I adjust the speed at which the table moves. So to kind of understand, if you're not into machining, what it's like, if all these rotations of the handle you see, if I'm trying to size apart, surface apart, drive the table away to take a measurement and back underneath the chuck or collet, that's all done by hand without a motor, and you can do it. It gets pretty tiresome. It's tedious. If you're surfacing something, it's really, I won't say it's hard, but it takes practice to get a good finish, because you need that consistent speed, you need the right speed, and you need to be able to repeat it. So in all honesty, I actually did pretty well freehanding the finishing surfaces, but anyway, it's much better now with a motor. So see, back to where to start. The parts that make this up are a 12-volt computer power supply, and I've got it strapped to the back to the motor there. That point at which it's strapped does not get hot. I verified that before I put it there, and the zip ties are holding it in place. You know, they're kind of locked up by the screws. So just a simple way to get it mounted out of the way. Because it doesn't come with a switch, and because my DRO switch is on the back side, and I was just tired of flipping it around to find it and everything, I went and got a, I'll call it a Christmas tree outdoor switch. Comes with a remote, which I usually keep in a drawer so I don't lose it, and I took it out to turn it on for this, and I've lost it. There it is. So anyway, it comes with a timer and photo sensor and a remote. So anymore, when I want to turn the motor power supply on and the DRO on, I just reach in this little drawer here and turn it on with my remote instead of having to reach behind it or whatever. No big deal, but it's pretty handy. So 12-volt power supply from the computer, of course the wiring assembly coming down, and I've got it wrapped up to this point and over to the electronic speed control to the double pole double throw switch, off right left, and out from the switch to the power seat motor. The power seat motor, scratch that, we're going to back up a little bit. So to mount it, I had to come up with a way to interface the motor, and I believe that's lead screw is what you call that, with the shank from the shaft rather, from where the handle was removed. And so I'll take this out of the way. This is back to where I talk about simplicity. I left one screw so I can tip it out, and this is removable. I'll talk about this in a second. So that's, when I remove the handle, that's what I'm left with. And some of those other guys, they did, you know, drill a hole, use a pin to interface. There's a couple different ways you could do it. Again, I didn't want to make mods to the machine if I didn't have to. Just because it's just my nature to not I won't say bastardize, but not modify unnecessarily. And so what I did is I made this. This was going to be turned down on a lathe, but I don't have a lathe. It's on the list. One day I'll get a lathe. But what I do have is a 3D printer, and I don't know, probably would. This has turned out so well, I'm not sure it would have ever been worth wasting the time on a lathe. I shouldn't say wasting time, it'd have been fun. But anyway, for those of you that are wondering why, okay, just to give you a heads up, you're going to see a couple stitches going on here. Apparently my phone only records for so long before it stops. Anyways, this is a 0.8 millimeter nozzle on my extruder for the 3D printer, so it puts out really big layers. This is the first thing I printed with it. I'm having a hard time with focus here. This is the first thing I printed with it, and in some ways it came out kind of sloppy, but it's very strong and works really well. I don't think it's gonna break anytime soon. So I drew it up, 3D modeled it, obviously to match the handle, the interface right here. And what I had done previously, if I have the old one handy, is I had been experimenting. You know, I've tossed it in a drawer somewhere. Anyway, and I'd made a through hole, same size to fit this shaft, all the way. And then I had just literally banged a socket into that hole with a mallet, and used a 1/4-inch adapter to be able to run socket off your drill, hex adapter. I just used that to interface the handle, and played around with it just using the drill. So then when I got the motor, first thing I did is this is very long. I left it regular length. I'll probably clean it up, shorten things up later, but for right now it's working good. So what I did is I just threw the motor up in the vise, and I milled the edges of the lead screw flat at a 1/4-inch interface. So they fit a 1/4-inch socket or 1/4-inch homemade printed adapter equally well. This is just some vinyl tape that I wrapped. I milled that up to about here, and so of course, having done that, the intent being to cut that shorter, and then have the thread be the stop point. Having done that, this will slide. It'll work its way up the shaft and out of the engagement here. So I just use that tape as a stop. That's all that's doing there. It's just again, stuff that if I get bored, run out of other things to do, I may clean up and do other things about it. But it works. It's functional. It's not super ugly. I'll let it roll around in my head until I come up with something better. So yeah, so this is 3D printed, but it could be turned on a lathe and then milled, to make the interface there. 3D printing's kind of a lot easier if you ask me, but to each their own. It's way easier if you don't actually have a lathe. It's was my only option. I could have got away with turning it at work on lunch break or something, but technically you're not supposed to do stuff like that. So this handle here, just real quick, this little notch, this is a Lowe's or Home Depot bought out of the little drawers there. It was $1.50 or something, and what I did is this is an M8 by 1.25 threaded insert for the stopper blocks that run in here. So I beat the standard nut out of it, rethreaded it, epoxied it back in place, and then put a longer bolt in. So essentially what this does is this interfaces the sliding block that goes with the table stop that was already there. So I removed the table stop and the original bolt. They're in a drawer, and replaced them with the rail and the longer bolt that the handle recess this handle so the screw would insert in. And the whole point of this is so that I can slide the whole assembly out and disengage it as I've done here. And the reason you want to be able to do that is, and I wouldn't slide it out probably that far, but I'd slide it out to like right there. And the reason you do that is because there's a lot of actions where you've got to be able to turn the handle by hand. You've you're dialing in holes you're going to drill, you're doing edge finding, etc. You don't want to be fighting the motor, because there's no clutch, there's no release. If you don't disengage the motor, then you're turning against its own resistance. So that takes a little more effort than is desired. So this whole thing just slides, and if I slide it out, I'm going to run out of video here again in a second, I'm sure, but if I slide it out, you'll see what I've done here is I've milled a rail. I'm not sure how to explain that. I've milled a rail into the rail. But anyway, I've milled these edges on either side to leave an extrusion that engages the slot on the front of the table. And what that does is, of course, now I don't need two screws, or two bolts rather, to hold it level. The rail itself keeps the assembly level and square to or parallel, I guess, maybe, to the table. And then I just slide it into the stop and tighten that guy down, and now I'm back to the motor on. And then because I've got stuff kind of loose, it self-centers, for lack of a better term. You may have noticed that, I had things a little bit cockeyed when I first hit the button, and it just kind of drew itself in under torque. So that actually works pretty well. It wasn't a specific design feature, just something I noticed. I don't want to drag this out longer than I have to. I think I covered everything. The surface finishes that I'm getting are, it's hard to get it on video, but I'm getting a really nice surface finish. This was, this looked like that. On the back side is real rough and ugly. And then I got something like that out of it. And it looks, again, that's at 800 to 1000 RPM, running at like number 10 on the drive, super slow, with cutting fluid. 10's about the slowest I can go and get movement to start on the table. Actually, that's a lie. It's about 25. I may have something going on here, because I was running it as low as 10 previously, but I'll have to look into that. And then 100, I know there's no good reference, but there's the movement at 100. And if I go for minimum, yeah, I must have just been where the table, at the far edges, the table gets a little snug. So I'm back in the kind of the middle of the table movement, and it will drive. It will start at about 20, and it'll drive at 15, and it'll drive at 13. I don't know. I probably would never want to run it that low, because once it hit the resistance from a piece of material, I think it would probably choke. So maybe I was running it at 20 when I did that. I could probably get a way better surface finish. I say way better, it's not bad at all, but I mean, I could probably get a better yet surface finish if I sped up the spindle for the final pass. Now I'm taking like a 12,000th cut on the final pass, and at 800 to 1,000, I could probably crank that up. If I was at work, I would just reach up, grab the handle, and spin it up faster for that final pass and get a real nice, almost mirror finish. But like I said, this is belt driven, so I don't look for excuses to have to open it up and change the belt around. So I guess that's it. Anyway, hope it was at least interesting. Hope I didn't make it too annoying, moving around and whatnot. I see a lot of YouTube videos that cause motion sickness. So we'll see. If this one didn't turn out well enough, I'll delete it and try again before I post. Alright.